Now let's see the meaning of a schedule. So what is a schedule is, when you have many transactions coming in, you can execute the operations of the transactions in many ways, right? Like I can take one transaction and all the operations of it and execute them first and then start with the next transaction, right? If I do that, it is going to be one type of schedule. Or I can execute some of the actions of or operations of one transaction and then execute some of the operations of other transaction and again come back to the first one and again come back to second. If I do that, that is also a kind of schedule, right? So schedule is nothing but what is the order in which you are going to execute the operations of various transactions when you have more than one transaction. If you have only one transaction, then you have no other way. You are going to execute from top to down. So there is no way you are going to get many schedules. But then when you have more than one transaction, then you are going to get many schedules possible, right? Now I'll just read out the definition and give you the examples. Now see this. What is a schedule is? A schedule represents the order in which the operations of transactions are executed. So what is the meaning of it is, I'll just take an example. Assume that our database has got two transactions. Our database server has to execute these two transactions, and one transaction is T1. I'll just take a simple example, assuming that there are only two operations present in transaction T1, and the other transaction, let's call it as T2, is having only two operations. Just an assumption. Generally two operations are not possible, but I'm just assuming it so that explanation will be easy, right? B1 and B2. So what is the meaning of it? In order to execute the transaction T1, the operations that have to be carried out are A1 and A2. In order to complete T2, the operations are B1 and B2. Now what are the various ways I can execute these four operations is, that is going to form schedules, right? So there can be one schedule of this type, T1 and T2. I can execute completely T1 first and then T2, right? So A1, A2 and then B1, B2, right? So this is one type of schedule, and the other type of schedule is, I can execute, let's say T2 first and then T1, which means B1, B2 operations will be done first and then A1, A2. This is other type of schedule, right? Similarly, you can have some other type of schedule on which, let's say I start with one operation from T1, which means A1, and then I'll do one operation from T2, which means B1, and again I'll do one operation from T1, which means A2, and then one more, right? This is one schedule, right? Similarly, I can have one more schedule like this. I can start with one operation from T1 and then I can finish T2 and then I can finish T1, or other type of schedule can be, I can start with one operation from T2 and then one operation from T1 and then one operation from T2 and then one operation from T1, or other type possible is, I can start with this and then I'll finish up T1 and then I can end this one, right? Now if you observe this, these are the various possibilities we have, no more, you can test it, right? So one thing that might be confusing you is, you might also think that this type of schedule is possible. Let's say S7, you might think that this type of schedule is possible. I'll start with A2 and then I'll start with B1, B2 and then A1, right? Now this can never be a schedule. The reason is, within a transaction you are supposed to follow the order. If you look at the order, within a transaction A1 should be done first and then A2, right? So this should not be altered, right? If you look at any of these transactions or schedules that I have written, within a transaction you are always going to have the order. Now if you look at this, the order is A1, A2 and B1, B2, right? If you look at this, order is A1, A2, B1, B2. Here also A1 and then A2, B1 and then B2, A1, A2, B1, B2, A1, A2, B1, B2, A1, A2, B1, B2, right? So if you look at it, I'm following the order, right? So with these two transactions with two operations each, how many schedules are possible? 6 schedules are possible, right? Now if you don't let any control, if you assume that no concurrency control mechanism is applied and you are simply allowing the transactions to interleave and operate, then they might execute in any of these possibilities, right? Now how many of them will lead to the correct answer? That actually depends on what types of operation they are. If there is no intersection between them, which means these two transactions, if they are not operating on any common data item, then all of them might be true if they are completely independent, right? But then if they are dependent, then depending on their actions, some of the transactions might lead us to wrong answers depending on what problem, the problems we have seen earlier, right? If some of the schedules are leading us to the problems that we have seen in the earlier examples, yes, that might be wrong. But you can be very sure that 2 schedules among these will always be right. So what are the 2 schedules? This one and this one, right? So if you look at these 2 schedules, this one and this one are actually serial schedules. Why serial is, you are letting one transaction completely be over, then only you are starting the other one. Here also you are letting this transaction be completely over and then you are starting this one, right? Therefore these 2 are called as serial schedules. So with serial schedules there is no problem at all and always they will lead us to the correct answers. But the only problem with serial schedule is your performance might be hurt. The reason is, some of them might be IO operations, and if you wait for IO operation to complete without starting the next transaction, then it might lead to the performance issues, right? So what you should do is, even though the serials are correct, you are not always going to execute the serial transactions. You have to execute the schedules in which some concurrency is allowed in such a way that it will not hurt the performance as well as the result is right. Which means among these schedules, find out the schedules which are equivalent to the serial schedules and then execute them. Got it? Okay, how to find them, what are the rules, we shall see them later. For now let's stick to how many schedules are possible. Now with these many transactions and these many operations, these many schedules are possible. Is there any general rule we can apply? Yes. Now assume that I have T1 with n operations and T2 with m operations, right? Then how many ways I can form the schedules is, the formula is n plus m factorial divided by n factorial into m factorial. So how to get this? We have discussed about this in mathematics. In permutations and combinations, I have given you some examples. I'll just tell you how we get this. Now you can sum them all up and find out all the permutations possible. You take all the operations together and you find out all the permutations possible. It is going to give us n plus m factorial, right? Now we are not supposed to change the order within each transaction, which means even though this transaction is having n operations and this transaction is having m operations, you are not supposed to put all these n in any permutations. They have to be always in that order, right? Now if you are going to get all the permutations, most of them you got because you are permuting this one, right? Now if you compute how many you got because of permuting this one, you will see that it is n factorial. And how many you got here? M factorial. Therefore you have to divide them, right? Because many of the transactions in this one actually represent one and the same transaction. Therefore you are not supposed to change the order. That is why I am dividing it with this. Or if you want to clearly understand why this is true, better you watch permutations and combinations, you will understand it, right? So what I mean to say is, all these n operations, A1, A2, A3, so on an, have to appear in the same order within the schedule, and B1, B2, B3 have to appear in the same order, right? Now you can you can have any combinations of these two, but then the ordering has to be maintained, right? So the relative ordering between these n operations have to be same, and the relative ordering between these m operations have to be same, right? Now this number we got, assuming that we are going to change the ordering between this and the ordering between this, and then we have to cancel that effect. That is why I am dividing with n factorial into m factorial. Now in this case, n and m are 2 and 2. Therefore, what is that you are going to get here? 2 plus 2 factorial divided by 2 factorial into 2 factorial. Now if you compute it, this number is going to be 4 factorial divided by 2 factorial into 2 factorial, which is 6. Got it? So that is why you got 6 schedules. Now out of the 6 schedules, 2 are going to be serial schedules, right? And all the remaining are going to be non-serial schedules. Got it? Now if you have, let us assume n transactions, T1, T2, T3, so on, Tn, n transactions, and let's say the number of operations in each transaction is A1, A2, A3, so on, An. Then how many schedules are possible? The number of schedules possible will be A1 plus A2 plus A3 plus so on plus An divided by A1 factorial into A2 factorial into A3 factorial into so on into An factorial, right? This is the total number of schedules possible, right? Now out of these schedules, how many schedules will be serial? Serial means we have to execute completely one transaction and then next one and then next one, like that, right? Now how many is it possible? So you are going to get n, with n transactions you are going to get n factorial serial schedules, right? This is the total number of schedules possible, and this is the total number of serial schedules possible. Now if the question is how many number of non-serial schedules are possible, then from the total number of schedules you can subtract the total number of serial schedules, then you are going to get total number of non-serial schedules. Got it? And non-serial schedules can also be called as concurrent schedules. Why? Because you are actually mixing up the operations. Whenever you mix up, it is concurrent execution. Got it? Okay. Now let's look at this problem. Find the number of schedules possible over 3 transactions with 2, 3, 4 operations respectively. Then they are asking about the total number of schedules possible. It is going to be 2 plus 3 plus 4 factorial divided by 2 factorial into 3 factorial into 4 factorial, right? So you can compute that number. So if you compute it, it is going to be 9 factorial divided by 2 factorial into 2 factorial. It is going to be 1260, right? Out of which, if you want to find out serial schedules will be 3 factorial only. Why? There are only 3 transactions, right? Which means 6, right? So these many possible ways are there to execute this these 3 transactions, but if you execute them in all these all these possibilities, your answers may not be right. Therefore, what our transaction management system should do is, it should allow only some of the schedules to be executed which are going to be equivalent to these 6, any one of these 6 transactions, because they are only going to give us the correct answer, right? So finding out them or ensuring that it happens is very important. For that we shall use some rules to make that it happens. Okay, fine.